Today I want to discuss triple integral. Let let f of x y z be a function defined over a region R. Then the triple integral of f of x y z over R is given as given as triple integration over the region R f of x y z dz dy and dx, and this we can give in other way also. Triple integration over the region R f of x y z dv, where dv means dx dy and dz. Now let us take some simple example. Here you see that if I have the limit of xyz constant, then I can easily evaluate it one by one. But if the limits of xyz integral limits are not constants and they are functions, then the evaluation of triple integral is somehow it is time taking. Now let us start with a simple example. So let us start an example here. Evaluate integration over a integration over 0 to a, integration over 0 to b, integration over 0 to c, xyz, and then dz dy dx. So here we can see that the integral limits are 0 to a, 0 to b, 0 to c, where a, b, c are constants. So we can integrate this one somehow easily. So first, suppose I will say that inner integral is z, the limit of z will be 0 to c, and this next inner integral is y, and the limit of y will be from 0 to b, and the outer integral will be x, and the limit of x will be 0 to a. And so I can write this one in this way: integration 0 to a, integration 0 to b, and then integration 0 to c, x, y, z. First I will integrate it with respect to z, then I will integrate it with respect to y, then finally I will integrate it with respect to x. Now you may say that, sir, why we will integrate with respect to z, why not to x or y? So you can do that one by writing the appropriate limit of x, y, z. So now one by one, if I integrate 0 to a, integration 0 to b, and xyz integration with respect to z will be xy and z square by 2, and the limit is 0 to c. Then I will integrate it with respect to y, and at the end I will integrate it with respect to x. Now, if I simplify again, integration 0 to a, integration 0 to b, and if I put the upper limit and lower limit, I will get here c square by 2, and then xy dy dx. So this we can rewrite as c square by 2 is constant, then remaining thing is 0 to a, 0 to b, and then xy dy then dx. Now we can further simplify here: c square by 2 integration 0 to a, Now I will integrate it with respect to y. So we will get xy square by 2 and the limit is 0 to b and then dx. So that means I will get c square b square by 4 and remaining thing is 0 to a x dx. So finally what will be the value here? C square b square by 4 integration of x is x square by 2 and 0 to a. And my answer will be ABC divided by 2 to the power 2. Or you can say a square b square c square divided by 8. So like this we can evaluate the triple integral if the limits of the integrations are constant. Now I will take another example of triple integral. Evaluate integration 0 to 1 integration 0 to x integration 0 to root over of x plus y and then z dz dy and dx. Now in this integration you see that the limits, the first outermost limit has constant, outermost integral has constant limit 0 to 1, then next inner integral has the limit from 0 to x and the innermost integral has a limit function of xy. So when you are having the innermost part as function of xy, the first integration will be with respect to z. That means z is the innermost integral, and then you see second integral has a function of x, and so next integral will be with respect to y, and finally the outer integral will be with respect to x. So now we will evaluate it one by one. So integration 0 to 1 and I will write integration 0 to x and then integration 0 to root over of x plus y and z dz will be first and then dy and then dx. So here we don't have the independent of having integrating any one of them first or any one of them second with appropriate limit. We don't have that luxury here. So now we will integrate one by one here. This equal to integration 0 to 1 and integration 0 to x and then integration of z will be nothing but z square by 2 and the limits are from 0 to root over of x plus y and then dy then dx. Now we can put the upper and lower limit. So the limit of upper limit of z is root over x plus y, lower limit of z is 0. So if I put 1 by 2 is constant, I can take it out. So integration 0 to 1, integration 0 to x. Now if I put upper limit, z square means root over of x plus y whole square. That will be nothing but x plus y and z is 0 means that will be 0, so no lower limit. Then I will integrate it with respect to y and finally I will integrate it with respect to x. And what we will have here 1 by 2 integration 0 to 1 and the integration of x with respect to y will be xy, integration of y with respect to y will be y square by 2 and the limits are 0 to x. After putting the limit, I will integrate it with respect to x. Now here I can have 1 by 2 integration 0 to 1. Let me put upper limit for x, y because here I integrated with respect to y. So I have to take the limit of y and limit of y are nothing but 0 to x. So wherever y is there, I will put upper limit x. So here I will have x into x square and x square by 2. So I will have x square plus x square by 2 and now I will put lower limit wherever y is there I will put 0 and so x into 0 0 0 square by 2 0. So no lower limit, then I will integrate it with respect to x. X square plus x square by 2 is nothing but 3x square by 2, and so 3 by 4, and the remaining thing is 0 to 1 x square dx. And so finally what will be the integration? 3 by 4 x cube by 3, and the limits are 0 to 1, and it will be 3 by 4 into 1 by 3, and that is equal 3 3 will get cancelled, and it will be 1 by 4. So like this we can evaluate the triple integral. Another example I will tell here is evaluate 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 integration 0 to a integration 0 to b into 1 minus x by a integration 0 to c into 1 minus x by a minus y by b. And here we can take x square z dz dy dx. So here you can see that the innermost integral has the limit function of x and y. So the most innermost integral is first with respect to z. Then you see second inner integral is having function of x. So next integral will be with respect to y, and then last one will be with respect to x. So we can rewrite it in this way: integration 0 to a x square is independent with respect to z and y. So I will take it out, and then integration 0 to b into 1 minus x by a, and then integration 0 to c into 1 minus x by a minus y by b, and then I will start with z dz. After that I will integrate with respect to y, and at the end I will integrate with respect to x. Now let us integrate the inner thing. So we can have here integration 0 to a x square integration 0 to b into 1 minus x by a, and here integration of z will be z square by 2, and the limits are 0 to c into 1 minus x by a minus y by b. After that I will integrate it with respect to y, then with respect to x. So here, since I integrated with respect to z, so wherever z is there, I will put upper limit as well as lower limit. Upper limit of z is c into 1 minus x by a minus y by b, and lower limit of z is equal to 0. So now 1 by 2 is constant, I can take it outside. Integration 0 to a x square integration 0 to b into 1 minus x by a. Now wherever z is there, I will put the upper limit as well as lower limit. So c square 1 minus x by a minus y by b whole square, and z equal to 0 means 0, so no lower limit will be there, dy into dx. So again you see that c square is constant, so we can take it outside. C square by 2 integration 0 to a x square will be as it is. Now the remaining thing is 0 b into 1 minus x by a, and then 1 minus x by a minus y by b whole square dy then dx. Now you can integrate it like integration of y square, because we are integrating with respect to y, x and 1 will be constant. So here something you apply 1 minus x by a minus y by b equal to t, and you can substitute and you can integrate it. That is also one way. Or directly you can consider this one like in y square, and you can consider the integration. So if you integrate it, you will get like this: c square by 2 integration 0 to a, and integration of this minus 1 by b is there, so that minus 1 by b will be minus b. So minus b into 1 minus x by a minus y by b to the power 3 divided by 3 divided by 3, and the limit of the integration will be nothing but 0 to b into 1 minus x by a. Then I will integrate it with respect to x. So here what we will get? So this minus b I can take it out. So minus b c square by, this 3 is also there, so I will take it out, 6. This will be 6, and now integration 0 to a. So these are the limits of y, because I integrated with respect to y. So wherever y is there, I will put upper limit b into 1 minus x by a and lower limit 0. So if I put the upper limit wherever y is there here, this value b will get cancelled, so I will have 1 minus x by a minus 1 minus x by a, so that will be 0. So upper limit will be 0, and lower limit 0 means y will be 0, so minus 1 minus x by a. X square is there, of course x square will be there. So this is the upper limit and lower limit, then I will integrate it with respect to x. So this is q, this is q, and so what we will get here, this minus and this minus will be plus, so I will have bc square by 6, and this one will be integration 0 to a and 1 minus x by a to the power 3 into x square dx, to x square dx. Now you can open the bracket bc square by 6 integration 0 to a, x square will be as it is. If I find the cube, I will have 1 minus 3a square b. So minus 3x by a. Then 3ab square. 3ab, a is 1, b is x by a. So we can have, I am using this formula, a minus b whole cube formula. So this is equal to a cube minus 3a square b minus plus 3ab square minus b cube. I am using that formula, and then here I will get, so I will get 3 by a square into x square, and then minus x cube by a cube, and we will integrate it with respect to x. So again we can rewrite it as bc square by 6, and this one integration 0 to a x square minus 3 by a x cube plus 3 by a square x to the power 4 minus x to the power 5 by a cube. And now we will integrate it with respect to x. So if we integrate it with respect to x, we will get bc square by 6, and integration of x square is x cube by 3, and then integration of x4 is x3 is x to the power 4 into 4a, and integration of x to the power 5 is 3 by 5a square into x to the power 5, and this one will be x to the power 6 divided by 6a cube, and the limits are 0 to a. So this will be nothing but bc square divided by 6 and a cube by 3 minus, here upper limit is a, so x to the power 4 means a to the power 4, another a is there, so I will have a cube by 4, and then here I will have x to the power 5 means a to the power 5 divided by a square means 3a cube by 5, and this here a to the power 6 divided by a 3 means minus a cube by 6, and lower limit will be 0. So if you simplify this, then you can able to get the answer, and the answer will be nothing but a cube c square b s q c square b divided by 360. So like this we can evaluate the integral.